Hey, good afternoon, everyone.
Afternoon, Professor.
Yeah, how are you, Antonio?
I'm doing good. How are you?
Good, good. So I see four people currently in the collaborate. So let's see. Oh, and Yosahani just left again. Um, okay, hopefully the rest of the class, one person is reconnecting. That was Yosahani, and so let's see how many people are in the forum. All right. All righty. So I have five people, and so and I also I have four people here. So one more person still needs to join the collaborate. Um, well, you guys must be aware that my computer broke down last week, and I haven't got a chance to get it fixed yet. So I'm still relying on my old computer. Um, I will. Uh, it's just very inconvenient. I just need to make sure. I just need to uh, use whatever resources I can. So that's making it kind of difficult. But anyway, let's. In the last class, we were talking about. We just got started on the multiple cash flow model in the last class. So here's the I believe, and then I was explaining the, let me use this thing, uh, whiteboard provided by the blackboard. Okay, that's kind of weird, but and so we were talking about, let me use something darker. In multiple cash flow model, right, there are multiple cash flow model. There are basically annuity, and free form or irregular, right? Free form. Yeah. Annuity is it's not just annual, but it is basically regular. There must be a regular payment or deposit, at regular interval. So annuity, just because the name is annuity, uh, it doesn't have to be annual payment or annual deposit. But the point is, there has to be regularity until certain maturity. So let me okay, but once I switch, then it makes it very hard to quickly switch back and forth. But so let me start with the let me talk about the free form. Um, in case of annuity, uh, we're gonna look at the example later, but uh, you can think of let's say you got a loan from the bank, and if you have a loan from the bank, there's a let's say you have a $100,000 loan from the bank for 10 years, right? For the 10-year period at 10% interest rate a year, and then you might think, well, so I can pay back in 10 years with future value. I mean, 10, so you might think, 100,000 times 1.1 raised to 10. Oh, that's my future value. That's what I owe the bank. Uh, no, the bank won't wait 10 years. The thing is, in reality, the bank won't wait 10 years, so it's not going to work like that. The bank wants you to start making the payment from a month later. I mean, you took out a loan today, and the payment starts already from the end of this month. Okay, and every month they want you to pay back in installment, right? So in that case, your installment is regular amount. It's always the same amount, and at regular interval, monthly. So that fits the concept of annuity. As I said, no lender. Think about it. There's no lender in the world that will give you 10 years, right? That will just wait, just hands down 10 years, right? Uh, so in reality, uh, uh, you're not paying back the future value if you have a loan, right? Uh, now, and the example of free form is, let's see. So you're making a, let's say, people generally, save money at sporadically. I mean, there are people who make uh, regular savings, regular, but generally people just make deposit um, at any time and in any amount that they can afford. So let me just make this smaller so I can have a space for. And so in case of free form, it's irregular. I mean, the point is, everything is irregular, right? So for example, we have, let's say we have 3-year timeline. And 3-year timeline would require like, time zero as So time 0 is the beginning of the first year, right? Time 1 is the end of first year, right? Time 2, that means, end of the first year, beginning of the second year, right? Time 2 is the end of the second year, beginning of the third year. Time 3 is the beginning of the time 2. Time 3 is the end of the third year, beginning of the fourth year, right? So suppose you're making at time 0, you made a deposit of 1K, and at the time, interest rate was 5%. And you're making a deposit of 1.5K at the end of year 1 or at the beginning of year 2. And then at the time, the interest rate was 4%. And at the end of year 2, at the end of year 2, at the beginning of, which is the beginning of year 3, you made a deposit of 2K, right? But you get the idea. And at the time, the interest rate was 3%. What's going on? Why isn't it? Now let's think about the future value at the end of year 3. Now, so future value at the end of year 3, we will have then the future value of this thing, first 1K, will earn interest in the first year. It's going to earn 1.05, and this whole thing will earn interest it will grow by the factor of 1.04 in the second year, right? 1.04. And then in the third year, it will earn interest of 1.03, or it will grow by the factor of this, right? And the second deposit, $1.5K, which was, at the deposit was made at the beginning of year 2, right? Or end of year 1, right? It's going to earn only, it has 2-year timeline. So it's going to earn interest like this. And then 1.03. This is a, fairly easy question to understand. But some students, there's an example like that, problem like that in one of the chapter problems. And this 2K will earn interest for only 1 year, right? This 2K will earn interest of 3% just for 1 year. And then future value in year 3 will be the sum of all of these, right? But think about it. This is what I call free form because there are, um, irregular. I mean, you're free to deposit whatever amount and at whatever point. I mean, you don't even have to make that deposit in year two. I mean, it can be at any year or at any point. So it's free form, and the interest rate will depend on the market rate of that year, right? But this is not difficult to understand. And our focus is more on annuity. Okay, so what is then? So here's a. Oh, here's an example of annuity. Excuse me. Now, so let's take a look at this diagram. First of all, what you can see here is that you have a 5-year timeline, and through this 5-year timeline, you're making a $1,000 deposits at the end of each year. Okay, and the interest rate is 20%. So obviously, to have guaranteed 10% interest rate, you got to lock into some contract, right? So annuity account, you'll have to open an annuity account, and you got to lock into a um, constant interest rate. But for that, you must also make a regular payment or deposit at regular interval, right? If you cannot stick to that, then it's not going to work. And the point is, um, to this is called annuity, right? Annuity. So annuity is a regular payment or deposit of regular amount at regular intervals. So it fits exactly, right? Uh, until a certain maturity, right? And I said payment or deposit because uh, deposit and payment are two sides of the same coin, right? Think about it. If you think you're making a deposit, um, but suppose you borrowed money, right? And if you borrowed money, uh, like a loan, right? $100,000 loan, like the example I already gave you. You have $100,000 loan at 10% interest rate for 10 years. Then how would you pay it back? You can't pay it back 10 years later, right? You can pay back like future value of that 10 years later, because the lender, the bank, always wants you to make payment already starting from the next month. So it's an annuity. And then when you are paying back monthly, when you're paying the monthly payment, what do? You make the deposit into the designated account because you're writing a check, or you'll be writing a check basically, uh, And then when you're when that check goes into that account, that gets deposited, of course. But then there's a payment, isn't it right? From your end, it's a payment, right? Uh, so basically, payment and deposit are two sides of the same coin. So when I say payment uh, or deposit, you should be able to flexibly adapt it to the situation, right? And the payment is so the symbol. I mean, what do we call this? The symbol for this will be always PMT, payment, right? There is no symbol for deposit, right? It's because it's payment is the same thing. Then in this example, you will know what you can easily visualize the and even we can easily visualize how you can find the future value. First, you will the first deposit will the future value will be the future value of the first will be um, you will the that payment of 1,000 will earn 20% interest, right? And it gets compounded 4 times because it's exactly 4 years. From here 1, 2, 3, 4. It gets compounded 4 times. Second deposit will get compounded 3 times. Third deposit will get. So the last deposit will not get compounded at all because you are making a deposit at the end of the maturity, on the day of the maturity, right? At the end of year 5. So technically, it's technically deposit, but practically, you don't have to even put the money in anyway because it just dips into the bank. You just dip it into that account, but you take it away right away. So the bank doesn't even use that money, have time to use that money. The bank doesn't even get a chance to use the money, right? So what's the point? But still, formality. You might think, so you don't have to make it, but the technicality requires that it must be deposited anyway, right? There must be a record of deposit, although you're taking it out right away. And you will see that the number of compounding is always less than n minus less than one. I mean, less than it's one less than the total number of, right? The maximum number of compounding is the highest, uh, always n minus one, right? In this case, n is 5, but maximum number of compounding is 4, right? And actually, this one has zero compounding. In other words, um, think about it. You can think of it as 1,000 times 1.02 raised to 0. And anything raised to 0 is 1, right? So it's just the same thing. But let's take a look at the second example. And second example, it's also 5-year timeline, a 5-year timeline. And the payment is $5,000. It's not 1,000. But ignore the difference in the payment and the interest rate, because in this example, interest rate is 10%, deposit 5,000. But ignore those differences. But the point is, if it was 1,000 or interest rate were 20%, it's the same picture except for one thing. What is that one thing? The deposit is made at the beginning of the year, beginning of year 1, year 2, year 3, year 4. So then, what's the difference in the structure? Difference in the structure is that the compounding is not n minus 1 times. I mean, the maximum number of compounding is not n minus 1 times, but it's n times. In other words, first deposit will get compounded 5 times, 5 times. Second one will get compounded 4 times, right? And even the last one gets compounded once. And the future value of all these annuities will be the sum of all these individual future values of individual deposits, right? Makes sense? That's quite easy enough. Um, but then the question is, when do we use this and when do we use this? Of course, depending on the assumption, right? If the assumption is that you are making a deposit at the beginning of the year, beginning of the period, then it's this. And this is, if otherwise, you're always making deposit at the end of the period. And the model above is called ordinary annuity, and the one below is annuity due. Annuity due means the payment is already due to begin with. Annuity due, right? Now, ordinary annuity is default, right? Unless otherwise stated. Ordinary annuities always default. That's why it's called ordinary, right? Annuity due is only under a specific instruction, meaning in the problem it will there is a clue. It will say annuity due, or it will say either the payment or deposit is made at the beginning of each period, something like that. Otherwise, it's automatically assumed by default ordinary annuity. But in reality, this diagram, you might think, oh yeah, 5 years, annual payment, easy enough. But look, in reality, this is only a simplified, extremely simplified example, just to convey the idea to you. But in reality, the actual example, the real example, would be more complicated than this. Why? First of all, then annuity may not be annual. It could be monthly, like the mortgage loan example I used. If the annuity is monthly, then the compounding frequency is monthly, right? 12 times a year. Even over 5 years, there will be 60 compoundings going on. 60 payments, 60 compoundings, right? So it's gonna get quite it's not something you can do it this way, because it's not impossible, it's not undoable, but it's gonna be very tedious. You'll have to have 60 terms like this, right? So, and if it is mortgage, let's say you borrowed, $500,000 to buy a house. That's a mortgage loan, right? And then your term of the loan is 30 years. And over a 30-year period, you will have to make 360 monthly payments, 360. So you certainly can't do it like this. So then how do we do it? That's why we need, a reduced form formula. Okay, I will get to the steps of derivation of this formula later. We don't have time today, but think about it. An example like this. So let's say you're planning to go to graduate school in 5 years. Okay, you thought about MBA program. So it will take at least 5 years to get your bachelor's. I mean, 4 to 5 years, right, to get your bachelor's first. Just But let's make it 5 years just to be, just to be on the safe side. And also these days, a lot of good, renowned MBA programs require work experience in the corporate sector, right? In the corporate headquarters. In other words, um, job experience they require isn't something like working in Burger King or part-time McDonald's like that. Of course, if you have worked at the McDonald's corporate center, corporate headquarters, Burger King corporate center, uh, that already requires like bachelor's degree at least. Uh, but these days, of course, they are much more flexible with the degree requirement. Uh, but just to be on the safe side, let's say your timeline is 5 years. Then our next question is, so how do you pay for it? And of course, a very prestigious schools, prestigious schools like MIT, um, Yale, Harvard, Ivy League schools, or uh, even if it is not Ivy League schools, it will cost you a lot. Um, at least somewhere between even state universities for MBA program, um, it can cost anywhere between 40K to 60K a year. Of course, it could be lower than undergrad tuition because in most undergrad tuitions, um, the dormitories, right? Dorm and in other words, room and board, meals, right, are all included. So it costs a lot more. And graduate schools generally live outside, so uh, it's not included in the tuition. So tuition is, mainly just for really taking classes. And some, other fees, but still, it's going to cost you a lot of. Uh, so so you looked at, you decided on CUNY, uh, uh, graduate center, or MBA will be offered by Zicklin School of Peru. Um, because CUNY is the most affordable. And even with CUNY, it's going to cost about 30K a year. And then for 2 years, it's going to cost you 60K. So our next question is, how do you pay for it? How do you raise 60K? So you have two options. If you have money, right? If you have like large sum of money, like uh, if you have a large sum of money, like 40K, then if the interest rate is good, 40K times 1 point, let's say something like 1.08, 8% interest. Is it possible? Yeah, I don't think it is possible. But let's just say 1.08 raised to 5 years, right? And single cash flow model, the future value will be like 58K, almost 59K. But again, we are still short, right? We're still short by about 1.3K, right? Because our target future value is 60K. So that's one way. And even if you so even if you had something uh, slightly more than 40K, 45K, maybe at 8%, you may reach the goal, may hit the target. Or otherwise, if you can find a bank that pays you 10% interest rate, it may do the job. But then the big realistic question is, who has 40K in their name? I mean, I'm not underestimating you, but most of you are um, in your early 20s, right? 19, 20, 21, 22, or something like that. And at that age, you're not likely to have 40K in your name, or 45K or 50K in your name. I mean, if you do, good for you. But in general, on average, and when I was your age, I was uh, almost 60 years ago. I didn't have a I had at best $1,000 in my name, in my savings account. At best, at most, $1,000. So uh, this is not a very realistic, right? Realistic scenario, isn't it right? Having 40K or 50K in the bank and wait for future value now. Um, so more practical or realistic option is um, making saving a regular amount at regular interval for 5 years. In other words, annuities, right? Annuities. That's probably it can do the job. Let's say you can save $800 every month. Let's say you have a part-time job, and you can save at least $800 every month. Then over 5 years, it's going to be 60 payments of $800, right? The total amount of deposit alone is already 48K. So if the interest rate is good, right? Think about all of the $800, right? Earning interest. The first one, interest, 59 times. The second one, 58 times, and so on. But think about it. Think about that. That may do the job. It may help you achieve your target goal of 60K, right? So then let's see how it's gonna. So we're gonna use this example, and I want you to download. Oh, I forgot to. So if you go to, we're gonna be using. Um, so here in topic 3, and in every topic folder, there are 2 files that you have to download. And when you were doing topic 3 by main lecture, you should have downloaded these files and use them with the video. And if you never knew that all this time, it's a shame. But download this one, right? This is the PDF file. This is the Excel file. It's shouting. It's already shouting out. This is Excel file. We want you to download it and have it in front of you. Of course, you downloaded this previously because while we did the single cash flow model, you downloaded it. So I want you to have it in front of you. And let me also go to. Let me open that. All right. So you will see the bottom tab. Am I sharing the screen, right? Am I sharing the screen? You can see this Excel file,
Yes.
right? Okay, good. So go look for the bottom tab that says multiple cash flow model. Okay, and you will and delete all the highlighted cells. Okay, delete all the highlighted cells. Delete all the highlighted cells. So first, this is exactly our scenario, isn't that right? This is our graduate school example. You make $800 deposit every month. Currently, the interest rate is 6%. Your timeline is 5 years. Compounding is monthly. So we know what is the. We first need to find the periodic rate and n, the actual number of compounding. So it's not a difficult thing. We already it's 0.5. Right? So there you go. And the actual number of compounding is 5 times 12 months. 5 years times 12. So 60 months, right? 5 years is 60 months. So then using our formula, which is payment times 1 plus r raised to n minus 1 over r, right? Using that formula, we'll do payment times, open parenthesis, open another one, 1 plus r raised to n minus 1, close parenthesis, divided by r. Okay, that's very simple. And hit enter. Oh, something's not right. Payment times 1 plus r. Oh, I didn't raise to n minus 1. I forgot to do 1, right? 1 plus r raised to n. Why F21? That's ridiculous. This F2 minus 1. And enter. It's 55,000. Then I want you to delete column H. 55,860. Okay, some people might say, hooray, I got it. No, you haven't got it yet. Why? What was our task? What was our task? Our task was how to find out how to hit our goal, target goal of 60K, right? So in other words, this is only the future value of these annuities, but we are still about $4,000 short of our goal, of our target future value. Then, how do we reach 60K? A couple of scenarios. First, we can increase our monthly deposit. Okay, or we can find another bank that pays a higher interest rate than 6%, right? I wonder if it is 8% in your Excel file. If it is not 8%, please change that to 8%. Another option is extending our timeline by 1 year, right? Well, too bad, but if you can't, if you can wait another year, then we might have accumulated more money. And then once you have done this, you don't need to do the other scenarios, right? You don't need to do solve the other scenarios one by one. We can just, copy this and drag it down. And then it's going to take care of everything automatically. That's the beauty of Excel, right? That's the beauty of Excel. So, if we increase our monthly deposit by $50, we are very close, but still about $700 short. So we know we are close, but this is we need to nail the exact amount. Now, if we find a bank that pays better interest, and even at 8%, we're still about $1,300 short, right? And if we extend our timeline by 6 years, by one more year to 6 years, then we overshoot our target. We'll have more money, $9,000 more than our target. That doesn't hurt, but then also you have to consider the opportunity cost of waiting 1 year, right? Can you afford to wait 1 year? But still, waiting one more year is still under your control. Making $50 more deposit every month, still under your control. Finding a bank that pays 8%, this is not under your control, right? You can search the banks, but banking is a very competitive industry. So one bank doesn't pay much better interest rate than another bank. I mean, they all center around the same, market rate, average market rate. Sometimes you may be able to find it, but it's not under your control, right? Makes sense. If lucky, if you find like a bank that pays 2% better, well, that's significantly better, right? And it's very unlikely that you can find a bank like that. Now, next question is, how about future value of annuity due? Annuity due, we talked about that. And when I talked about annuity due, what's the difference between the two? The difference between the ordinary annuity and annuity due is one more compounding. It's one more compounding, not one more payment. One more compounding, right? People get it confused. A lot of people think annuity due has one more compounding. No. Look at the number of payments. One more payment. No, it's not one more payment. It's one more compound. Look at the number of payments. They are same. 5 payments, 5 payments. But the difference is each payment in the annuity due has one more compounding. So that means the formula for future value of annuity due will be like this, which means, this is what? This one is ordinary annuity, right? This one is ordinary annuity. And then there's one more compounding. So if you have already found ordinary annuity, that means you can recycle that finding. You can recycle that finding and just give it one more compounding. So here, what you can do here is, so annuity due, I have already found ordinary annuity. It's just one more compounding. Cycle this, one more compounding, and then you drag it down. And there you go. So still, you're still about $4,000 short here. You're just about $300 short. I am $400 short. Still about $800 short. You're still overshooting, right? So our next question is then, instead of trying out different scenarios, is there a way we can nail? Is there any way we can nail the exact payment? Yes, we can nail down the exact payment. And we're going to talk about that after the break because it's 1:54 now. Uh, it's a good time, just about time to take a break. So we're going to take a 10-minute break and reconvene at 2:05. Okay, we're going to reconvene at 2:05. All right? All righty.
Professor, I think you're muted.
I'm sorry. Yeah, thank you for pointing that out. All this time I was just
Yeah,
talking
no
like,
problem.
all right, Jesus, I was just, all this time I was talking like crazy. Okay, so uh, again, again. Uh, so our next question was, how do we nail the exact payment? And I've been telling you, yeah, only this equation is already, this is the starting point. And no matter how complex any equation may look, right? The key to solving the equation is identifying z equals x times y structure. Okay, and this equation is already presented in z equals x times y structure, isn't it right? Uh, this is z, this is x, this is y. So solving for x is always z minus y, z divided by y. So payment is our x, and you divide FVA, future value of FVA, which is our z, by this y. But the y is in fraction, isn't it right? Y is in fraction. And dividing something by fraction is the same thing as multiplying by the reciprocal, by its reciprocal. So the reciprocal of the thing in the bracket will be r over 1 plus r raised to n minus 1. Okay, so we can, by using that formula, right, we can nail it. So uh, so this is exactly the reverse engineering, reverse problem, right, from this, um, because we already know our target future value, right? If we solve it with the target future value known, if we solve it backwards, we'll find payment. Before we do that, we need, the necessary intermediate variables, or intermediate inputs, which is periodic rate, which is APR divided by M, and then we know it's 60 months, but just to make 5 years times 12, there you go, and then we'll find, oh, okay, FVA times R over, open parentheses. Oh, something's not, it didn't go in. FE7. Oh, what happened? Why isn't G7 there? G7 times R over 1 plus R raised to N minus 1. Okay. Now, and there you go. Hit enter. We got this. And I tell you that when we tried out 850, we were almost close. So it should be somewhere, it should be something near, right? If we tried out 860, we would have overshot it. We would have overshot our target just a little, right? And also, I entered it this way. Of course, it doesn't make any difference whether you do it like this or like this. Doesn't make any difference, right? The reason being, um, we all know when you multiply something to a fraction, you just multiply it to the numerator. So it doesn't matter. I could do it like that. I can do it. Where the outer bracket is doesn't really matter, right? Now, then let's do another example. So it's pretty much the same scenario, but the only difference is that now your timeline is 6 years and your APR is 7.5 and the compounding is quarterly. And if that's the case, right, what should be the quarterly payment, right? What should be the exact quarterly payment? Of course, we can do the, simply divide our APR by 4, and then we'll 6 times 4, right? That will be 24 quarters in 6 years. And then we'll find out, okay, then FVA times FVA times R over open parenthesis, open parenthesis, open rather than, and plus R raised to N times 1, enter, and you should get this, right? So everyone got it right so far? Everyone got all the same numbers? Everyone got the same numbers? Right? Did everyone get the same number? I would have to assume that's yes.
Yeah, I did.
Did everyone get the same number? Okay, good. Now, our next example. And then I will let you use whiteboard. Now I think this is the new. All right. And then since we all know that in an equation or in any equation with n number of variables, right? All those n number of variables can be unknown in its own right. I mean, not all those variables can be all at the same time unknowns, but one variable, one of them can always be the unknown, right? One variable can be the unknown. So, in other words, if future value is the unknown, future value of the annuity is unknown, right? We can solve for it, right? If the payment, that means also, if the payment is the unknown, yes, we can solve for it. R is the unknown. And these two we have taken care of it. R can be the unknown, N can be the unknown. So then how do we solve for them? Here's the thing. So let me, again, share my screen. it's kind of pushed back here. To find n, this is the formula, this, okay? Uh, it's the rest of it is just steps of derivation, right? How it is derived. By now, you should understand that everything starts from the base formula and then going through every step, right? Going through these steps of transformation, right? Or steps of derivation. And then therefore, does anyone know what this, does anyone already is there anyone who already knew that this three dots means therefore? It means therefore, okay? These days, the math education is so poor, except for only a handful of people, they don't know math. Basically, math is a language, and a lot of, instead of, words, symbols are used, because it is symbols, it's universal. You're going to have therefore, right? Thus or therefore. So this is the formula, but look, it goes through this, steps of the, first of all, because n is the unknown, what do we need to do? We will need to isolate whatever we can. So I isolated, first of all, divided both sides by payment. So this gets, right? This gets canceled out. And then multiply both sides by r. So this gets canceled out. So in the right-hand side, I have only this left. And then plus 1, and this gets canceled out. And from here, we use natural law, right, on both sides. Voila. And the other one is for present value of annuity. You don't have to bother with it for now, because if there is future value of annuity, there's present value of annuity. Okay? So using this formula, right, we can find n. Some people, some students in the past got, daunted or scared. And they said, do I need to memorize all that? Look, you only need to memorize this, right? Now, this, they can't even tell. They can't even tell the difference between the steps and the conclusion. And then if, for those students, it's a pity. It's a shame that they can't tell the difference between the, the process, steps of, derivation, and the conclusion. And what about rate? What about R? Unfortunately, there is no unique mathematical process, right? In annuities, there's no unique mathematical process to for to find rate, because it depended traditionally depended on an iterative method. Iterative meaning you reiterate the same process over and over with different inputs. So in other words, it's also called a trial and error method. Trial and error is like trying out, guess first. You take a guess and try it out. If it doesn't work, then you try out another number. In other words, you have some candidates selected through your guess, right? Selected by your guess. You have few candidates. Throw in those inputs, those candidates. Whichever gets you whichever gets you the right number, right? Uh, Whatever gets you the future value, target future value, or the payment. But then this is not a very scientific method, right? It's like even the primitive man, the caveman, can do the trial and error method. You try out this, you try out this. It's like like old Aesop's fable, right? Old fable, Aesop's tale. There was this fox and uh, uh, two bears were arguing or two monkeys were arguing. Uh, Two monkeys were arguing whose banana is bigger. So I will. The fox came along and I will make it even. I will settle it for you. I will make the bananas even for you. He cuts out some. He eats the longer banana. Now it got smaller. So he takes the other monkey's banana. He eats the other one, and then it got shorter. So to make it even, he eats bites a chunk. He bites a chunk out of another longer banana. Then it got shorter to make it even, right? He took a bite out of the other one. Eventually, I mean, this is trial and error, but they never. The shrewd fox basically ate all the bananas um, under the pretense of making them even. But it's an iterative process, right? You plug in this number. If it is not, you try out something different. It can go up, go down. As it goes up, if it gets closer to the target, then you keep raising the number until you get the target. If it is lower, if the target, you put the number and you get higher than target future value, then you try lower numbers and until you get. But that's what even a fox can do, right? Or even a primitive caveman can do. It's an iterate. But ultimately, a computer is basically very good with iterative process. It can try out like 1,000 or even million numbers in a split second. So we'll have to use the computer. So here, let's get back here. What's going on? All right. So let's find. We already know it should be 0.5%. We already know, but given the why is it suddenly red? I don't understand. Okay. We know we have 60 months. 5 times 12. You go. And then finally, we will have to give the answer in annual rate because I've been telling you, all rates must be in annual form. All rates must be annualized. All interest rates are basically annual. So here, we'll find we're going to use rate function in Excel. I mean, if you have recently used it, it's going to show there. But if not, you got to go into the financial category and scroll down until you find rate. Okay, you find rate, and then give it what it's asking for. It's asking for end period, so you got to give it correctly 60, right? And then it's asking for payment. You got to input the payment, but you must make this. You must make this negative, and the negative doesn't mean, negative means cash outflow. right? And in a financial calculator, one thing must be cash outflow, and the other thing must be cash inflow. So payment is cash outflow in ours. There's no present value. We skip present value because this is not single cash flow model. There's no present value. And then there's no present value. But we have future value. So enter future value, right? And what is type? Type means whether it is ordinary annuity or annuity due. If it is ordinary, and by default, ordinary annuity is assumed. We assume ordinary annuity. Why? Because it's ordinary, right? I've been telling you, unless otherwise instructed, right? Unless the problem is clearly stating that this is like, annuity due, or either they won't say straightforward annuity. Instead, they will say the deposit is made at the beginning of the month, or the payment is made at the beginning of each period, and that means it's annuity due, right? And then if it is ordinary annuity, you don't enter anything there. You leave it blank or enter 0. If it is annuity due, you enter 1. And why you enter 1 if it is annuity due? I already explained this to you. Anybody? Why do you enter 1 if it is annuity due?
Because it's one more compounding.
Say, one more compounding. Yes, one more compounding. And who was that?
Aura.
Aura. Okay, Aura, you got 0.25. Yes, the reason we enter 1 is one more compounding. Okay, and I've been telling some people always say, one more payment. No, I said there's no one more payment. The number of payments are exactly the same, whether it is ordinary annuity or annuity due. But the difference is one more compounding. That's why you enter 1. But this is ordinary by default, so you don't enter anything or enter 0. Guess, if you get, there is no need for guess, because it already gave you 0.005, which is 0.5. Hit OK, it's going to give you 0.5%. But don't stop there. What did I say? Always the final answer must be in annual rate. And the annual rate is, if this is monthly, then this times 12, you're going to get exactly 6%. Now, finding n, we know the answer is going to be 60. So how do we do that? Of course, natural log of future value over payment, not yet, times r plus 1 divided by natural log of 1 plus r. And then if you hit enter, you must see 60 there. 60, there you go. Right? And then, how about in years? Of course, you divide n by m. You divide n by m. There you go, 60. Right? All right. Let's try another example. We found this already, right? Now then, the scenario is, you have the target future is still 60K. Currently, the APR is 7.5. You have 6-year timeline. Compounding is quarterly. Okay. Then, if that's the case, let's say we found, $2,002.52. But let's say we know monthly payment, and we know the time to maturity. Then what should be the rate? So we use the rate function, right? We use the rate function. There you go. And so you go down to find rate. Hit OK. Give it what it's asking for, end periods. Payment, which must be entered as negative. Okay. No present value. Future value, our target future value, 60K. And ordinary annuity assumed, we got the result, right? And then multiply that by 4, and we get the annual rate. And there you go. Okay. Now, finding n. Okay. So everyone is so far okay. So far, everyone got the same result. Everyone got the same result. Now, finding n. So natural log of value over payment times okay, and then what? R. Oh, so R is there. It's not filled in, but so it's gonna be filled in after I complete the formula, right? Plus 1 divided by natural log of 1 plus R. 1 plus R is missing. It's not going to give you any result, but once we have, so 1 plus the R, the periodic rate, is APR divided by N. Once it is N, we got that. 24 quarters. And the answer maybe, the problem must have asked, the problem would normally ask, how many years will it take? So then, 24 quarters divided by 4 should give you 6 years, right? So everyone got the same result? Everyone got the same result? Let me know if you have, let me know, please. If you got anything different, or if you're still having problem, let me know. No problem so far? All right. Then if you have no issues, right, then I will, that's all the time we have today. That's all the time we have today. So we'll call it a day here. We'll call it a day. I will have a great afternoon, and I will see you guys on Wednesday. Okay? Okay. I'll stop sharing, stop recording, and sign out.